Right, the other question is 1.4. Let's take a look at 1.4. Let me just zoom it a bit so we can understand what's actually required from us. So here we are. This is our 1.4. It says there with two equations. Let's take a look at the two equations. The first equation is this one. So first equation. Then we have the second one, which is this one. Good. And then they need to have, the key is that both of them, both equations, needs to have real roots. The roots must be real and they must be equal. So we are going to solve for both r and m. R must be greater than 0, m must also be greater than 0. So those are the keywords. So let's start with the equations. Let's start with the first equation. I'm just gonna copy down the first equation. The first equation says we have our x squared and then plus rx and then plus m must be equals to 0. So I'm going to focus first on this equation. I want you to have real roots. Remember, the real root will use the discriminant. We know that when we look at your quadratic equation, you'll have x equals to negative b plus minus the square root of b squared minus 4ac over 2a. So the discriminant is this part. This is our discriminant, the value under the square root. So our discriminant is equals to b squared minus 4ac. So for our roots to actually be real, instead we must have a real number inside the square root, and for them to be equal is if the b squared is equals to 0. So this must be equals to 0. So the b squared must actually be equals to 0 for the roots to be equal, because if this is equals to 0, what's going to be left will just be this. This is a b plus minus. So we're just gonna be left with b squared minus 2a, which will actually give us two equal roots. So our discriminant must be equal to 0. So we're going to find the discriminant of this first equation. So our discriminant for this first equation is equals to b squared minus 4ac. And noting that this will be our a, which is 1. This will be our a, and this will be our b. This will be, just write it down. So this will be our b, and then this will be our c. Which must take it with the sign. So we're going to substitute the discriminant, which is equals to b squared, which is r squared minus 4. What is my a? My a is 1. What is my c? My c is actually m. Remember, this must be equals to 0. We said the discriminant must be equals to 0. So it means our r squared minus 4m still apply. We follow the same rule. B squared must be equals to minus 4ac must be equals to 0. So our discriminant actual signs we substitute from this, and this will be our b. Let's look at our a is still 1, our a is still 1, our b is m now, then our c is r this time. So I'm going to have m squared minus 4, then a is 1, and c is actually r. That's good. And then this must be equals to 0, so we will have our m squared minus 4r is equals to 0. Then this will be our equation number 2. So we have two equations, we have to solve them simultaneously. We have the same variables, so we have two unknowns, we must have two equations. So just put that down. So it's up to us. Let's make m the subject of the formula. So if you make m the subject of the formula, this is equation number 1. We will have r squared. Our r squared being equals to 4m, and we divide both sides by 4. Divide both sides by 4 on that side, and our m is actually going to give us r squared over 4. So this is still equation number 1. This is still our equation number 1. And then we are going to substitute. When we substitute, just come to the side. Please don't forget that m is equal to r squared. Wherever I see m, I'm going to put the r squared over 4. So on the side, I will then have substitution. Will there be r squared over 4 divided by 4. Just make this much bigger, then squared minus 4r equals to 0. Just move it up again. This will give us r to the power of 4 over 60 minus 4r equals to 0. So I will just multiply everybody by 60. Just multiply by 60 side, multiply by 60, multiply by 60, and then this will give me r to the power of 4, and then minus 64r, then this will be equals to 0, and you will now see that you have a common factor on the side, which is r. So I'm going to have r is r, then r to the power of 3, and then minus 64, and then equals to 0. And then we have the solutions. Let me just put it down there. So also utilize the space aside. So I have r. I have my r being equals to 0. And then I have or and then I will have your r to the power of 3 minus 64 equals to 0. Remember the question said our r must be greater than 0 and our m must also be greater than 0. So this cannot be the solution for now. So because we have to find our solution from this guy. Then I move up a bit, then I'm going to factorize this into a cubic function. This is going to simply give move up. Let me factorize this a cubic function, and we have r, and equals to minus, to follow the sign, also check and verify to see how much you are going to get in terms of the root that you're going to get above. So this is what I want to